All right, so today we're going to talk about Beer's Law. And Beer's Law is a law that talks about or that relates the absorbance of a solution to its concentration. So it's broken down into this equation right here, A equals EBC, where A is the absorbance. This E, which is epsilon, is the molar absorptivity constant for a given solution. B is the length of the light path, so that's a distance. And then C is the concentration. So if we keep these two terms constant, which this is constant for each solution, and this we're going to keep the length of the light path, we're going to keep constant. It then relates to absorbance to concentration. So what happens is if we have a solution inside of some sort of container, we're going to shine light through it in this direction. So here's our little light source over here. We're going to shine light through it, and then the solution has to have some sort of color. And what happens is when the light hits the solution is going to absorb some of the light. And then over here, you're going to have a detector that's going to detect the beam of light and how much light passes through the solution. So what Beer's law says is, as concentration increases, so as if we think about this as being some sort of colored solution, as the concentration increases, absorbance will also increase because it's going to absorb more of the light. So if you think about, as concentration increases, this solution is going to get darker, and therefore become or be able to absorb more of the light until it gets to be like almost black, and then you can't see through it at all, and then it's going to absorb all the light. So this is going to detect less and less light getting through as we increase the concentration of the solution. A couple factors that play into this is we can change the wavelength of light. For instance, if we have a blue solution, something like copper sulfate or something similar, and then if we have a blue light source hitting a blue solution, well, a blue solution reflects blue light, so it's not going to absorb much. So you need to also pay attention to what wavelength of light you're actually using, because there's always going to be a best wavelength for certain colors of solution. So you don't want to use a blue light for blue solution or a yellow light for yellow solution. You want to kind of use the opposite for the wavelength. Okay, so that is Beer's law in a nutshell. There are labs that we do with this, in which we make varying concentrations, and then we figure out what the absorbances are for those, and then you should be able to get a good baseline, and you can use the absorbance to find an unknown concentration of a liquid, or if you have so a set of data points from some known concentrations. So let me know if you have any questions, and I hope you have a good day.